All right, here's today's experiment. I doubled the number of impulsor circuits. I basically just made an exact copy of the impulsor, and I multiplied the timing resistor by 1.125, and that allows me to have two different duty cycles that I can tune with this potentiometer, or this potentiometer here. So let me show that first. So here, let's just disconnect the coil so that I'm just running the pulsar circuits. And if I turn it on, it doesn't draw very much power at all. And if I look at, well, first, if I look at the bottom one, that's not right. Okay, the probe was on 10x. So this is the charge duty cycle, and this is the discharge duty cycle, and they're out of phase, 180 degrees out of phase. I'm not sure if that's the correct terminology, but the even pulses are the charges, or the odd pulses are the charges, and the even pulses are the discharges. And here's the circuit. Pretty simple. I have the wider duty cycle chip charging a capacitor, and I have the shorter duty cycle chip, which is set to fire when the charge cycle is off, powering this discharge MOSFET, which discharges through the coil. And I'm not using any resistance this time, because previously if I took the resistance out, then the circuit would draw way too many amps from the battery, and when the coil was hooked up. And now when I hook up the coil, I'm only using about 1/4 of an amp with no resistance in there. And you can see that even without the ferrite rod in the coil, I'm getting quite a bit of power out of this thing, where previously I had to have a lot more coupling between the two coils by inserting the ferrite rod before the neon would light. And that meant that means that the magnetic field that's being generated now is much more powerful, because the pulse that the capacitor is able to deliver, this capacitor here, has a much greater dV over dt than the battery is able to provide, the pulse that the battery is able to provide. So now if I measure across the coil, there's a fun little waveform here. And now it's interesting. So the ferrite rod doesn't have as much of an effect on the output anymore, but the ferrite rod does have an effect on how the input waveform looks. Just slightly. You can see, like for example right there, it's definitely out of phase just slightly. So if I pull the rod out just a tiny little bit there, we can match the next pulse up with the previous pulse a little better and get bigger spikes. Now, if I measure across the secondary, switching the probe into 10x, and switching the scope into 10x, get some really nice oscillations out of the secondary coil. And we didn't have to pay for any of those peaks on any of those oscillations. The only thing we have to pay for over here on the input side is the charging of the capacitor. And if I tune it while I'm looking at the secondary, we can see a much greater effect. Let's see if I go up to 50 volts per division here. So you can literally see it go in and out of phase there. And if I watch if I play with the inductance here, I can get the neon to go into different modes of discharge. It's a little difficult to see in the camera because it's so bright. You can just kind of see it from its brightness, but there's quite an interesting effect on the electrodes there.